conversation on human-computer interaction and the future of work. If possible, turn on your camera. We'd love to see you. Today we have a change of format and we have an exciting panel that will be moderated by Professor Chris Janssen from Utrecht University. I'd like to start by thanking the organizers, Andrew Kuhn, Linda Boyle, Rafaela Sadoun, John Lee, Manfred Siligi, and the National Science Foundation for partially funding this event. The first part of the event will be recorded. We're very much looking forward to questions from the audience. Please type your questions in the chat, and Chris will monitor the chats for questions from the audience. So please stay with us for the second part. Following the panel, we will continue with an informal social event that will be an opportunity to reconnect with each other. So right now, I'd like to welcome Professor Chris Janssen. Thank you for joining us today, and he will introduce the speakers.
Yeah, thank you, Ori. It's exciting. There's all kinds of challenges in these times, but what I found exciting is that I get to talk to people that I would otherwise not encounter on my regular Thursday afternoon. So this has been very exciting. And today we'll be talking with 3 experts on human-robot interaction. All 3 have done very interesting research in this domain and also contributed to the scientific community and to conferences on human-robot interaction. I will introduce each of these speakers in turn. I will give a short introduction and I'll ask them an opening question. But I really encourage you to look at their detailed biographies on the website of the Future of Work of this series. So the first speaker that I'd like to welcome is from Maartje de Graaf. And as I can already tell by her background picture, she's from Utrecht University, which is also where I'm working, where she's an assistant professor in information and computing sciences. Her background is a Master of Science in Media Communication and a PhD in Communication Science and Human-Robot Interaction from Twente University. And Maartje's research focuses on people's social, emotional, and cognitive responses to robots. So the aim is to develop socially acceptable robots that benefit society. Now, Maartje, as an opening question to you, I'm quite curious, what are some of the most important factors or characteristics that can make a robot socially acceptable? And do you perhaps have an example of that?
Yeah, thank you, Chris, for having me. What I mean with socially acceptable robots is that we need to design robots in such a way that they have a positive impact on society. This is sometimes referred to as designing for social good. And to ensure this positive impact, we need to know more about people's social and psychological responses to robots and how these applications of robots develop in this light. So that's why I study this. And to look at more examples, I've seen that people need only little cues to see robots as social entities. So, for example, that the robot is seeking eye contact or have facial expressions during our conversations. People cannot help to infer minds from the robot. We think that it is thinking and have intentional actions. So we really need to know more about the psychology behind this and how that impacts the application and society as a whole.
Right, very, very nice. Well, it won't surprise you that this is something I'm very interested in hearing more about, so I'm sure we'll get to that. First, I'd like to introduce the second speaker, which is Wendy Ju. Wendy is an assistant professor of information science at the Jacobs Technion Cornell Institute at Cornell Tech, New York City. She has a PhD in mechanical engineering and design from Stanford and a master's in media arts and technology from the MIT Media Lab. Now, Wendy, I know a lot of your car research, but your broader research focuses on the design of human-machine interactions, particularly with automation. And a self-proclaimed signature of your work, and also something I know, is the development of novel experimental instruments to reveal how people will behave in a variety of future scenarios. As an opening question, I'm quite curious whether you can give an example of such a paradigm and highlight what an important feature is to consider in designing these novel future scenarios to understand these.
Yeah, I mean, thank you, Chris. I'm just so excited to be here and with such great panelists. Maybe one of the most notorious projects that we have is one that's known as Ghost Driver. So one of the things that is a big problem for studying autonomous cars is there's just not a lot of autonomous cars to study with. and the autonomous cars that there are owned by a few corporations. So if we want, as a public to be able to have some influence about how those cars behave and want to do research on that, that can be really difficult. So one of the protocols we developed was something called Ghost Driver, where a person drives a normal car, which is dressed up to look like an autonomous car by kind of putting additional sensors on, stickers. But the really important thing is when people look into the driver's window, they don't see a driver because we have our drivers disguised in a car seat costume. And then we actually have a protocol where we drive as smoothly and safely, but in different ways to on public roads to look at how people are going to respond to different ways the cars behave. And that kind of thing allows us to elicit the different reactions that people have, to notice what sorts of things people notice or don't notice, and to get this information in advance of actually having the technology deployed on the streets. So that's an example of the kinds of things that we do so that we can understand how people are going to behave. We also try to do a lot of work with virtual reality. One of the projects I'm most excited about right now looks at cross-cultural differences in driving. So we have two people driving the same virtual world in VR, and we can see like how they behave at intersections or when they have to pass each other or merge. But because everything is in VR, we can run the same study here and in Israel as easily, and then we can see, if Israeli drivers or New York drivers are more aggressive. Surprisingly, it's New York drivers. So that's the kind of work that we're doing.
Very interesting. So you were already ahead of time with thinking of how from different continents we can connect online and see how we're driving. So that seems to be useful these days. Well, before talking about that in more detail, I want to welcome and introduce our third speaker, Holly Yanco, who's a distinguished university professor and professor of computer science, and also director of the New England Robotics Validation and Experimentation Center, NERV, at the University of Massachusetts Lowell. She has a PhD and Master of Science in Computer Science from MIT. And we also found out that she has a Wellesley connection or it works at Wellesley. So this is also very nice through your Bachelor of Arts. Holly's research focuses on human-robot interaction and evaluation metrics and methods for robot systems and the use of robots in K-1-2 education to broaden participation in computer science. Another interesting feature is that, Holly, you have a new robot coming in today. So we might have a premiere during this session that the robot comes in. For the opening question to you, I'm quite curious, out of the domains, the education of children, because children are the future and we want to get them engaged with computer science and with robots. So do you have any insights on how children learn to interact and engage with these robots? Because maybe those also translate to us as adults in how we learn to interact with robots that are new to us.
Certainly. One of the programs that we developed for K-12 education is a program we call Artbotics. So students learn to build interactive art pieces that are robotic, but also if you want to learn about looping in computer science 1, we always do this stupid thing where we want to teach people about a for loop, and we teach them about compound interest. And nobody cares about compound interest tables, particularly now that the interest rates are 0, right? But it's such a boring example. Whereas what we do is we have these small little cars, robot cars. And if you've ever seen the spirograph game toy for kids that you make circles like this, well, we teach them how to make a pattern. And then the reason you want to loop is because you want to make that pattern many times to make a nice pattern. So we're using robotics as manipulatives in a large way in the K-12 education. But I think that one thing for me is that when you're trying to develop education for students at the elementary level, you're trying to think about how do I simplify everything that I'm trying to teach. And I think that has come out partly from work that I do in assistive technology as well. So I design a lot of robot systems for people with disabilities, both cognitive and physical. And I spend a lot of my time thinking about how do we make things easier to use, largely by making them simpler, which then I think benefits all of us. You're muted, Chris.
Yeah. I lost my mouse cursor there. Working on 2 screens, and then the mouse wasn't on the screen to unmute myself. That sounds very exciting. I liked the spirograph as a kid, but I would like it even more if it was steered by a robot. So like, I can see how you get lots of engaged children in the class there, and indeed this creativity is interesting to see how we approach this, right? Because there's more of a trial and error capacity, I can imagine, in such a situation. Now that I've introduced all three of you, and welcome once again, I want to see if we can more take turns and respond to a central topic. And one of the things that motivated me for trying to get this panel together is that I read an article on the BBC, robots will be everywhere now that COVID-19 is here, because people need to stay more distant from each other. So why don't we introduce robots? So I want to know, well, how can we make those that work? I'm not sure whether that will be the future, but you might have thoughts on that. Now, before we get to the will that be the future, my first very general question to all three of you is, well, what makes human-robot interaction actually work? And because turn-taking is sometimes difficult in these online environments, I thought I'd start with you, Holly, because you've looked at the domains of assistive technology and manufacturing. And these might be two domains where we might encounter more robots now, at least naively, that's what I'm thinking. So are there general characteristics of what makes robots successful or less successful in those domains, or features or that they need to have?
Sure. I think aside from those domains, I mean, I would claim that any domain in which we want people to use robots, a lot of these things are going to be common across all of them. You know, having the ability for someone to quickly understand what the robot is trying to do, that kind of legibility or understanding of what the system is doing, allows people to develop a trust of the system. If the system does something that's completely unexpected, you're not going to want to be near it or interact with it. So we need to develop systems that people can use easily. Of course, there's this kind of spectrum, because if it's easy to use your first time, well, by the time you're using it the 100th time or the 200th time, maybe all of that ease of use is really annoying. We're currently developing a scooter system, just like when you go into a grocery store, at least in the US, I don't know in Europe, there are scooters available that people can ride on to go through the grocery stores. We're actually putting a robot arm on top of that scooter as well, with the assumption that if somebody has trouble walking through the grocery store, they may also have trouble reaching the top shelf or the bottom shelf. And part of what we're doing to make that be usable is we're putting on a lot of language telling them what the system is trying to do. So I see what you want me to pick up, and I'm going to go pick up that can of soup. But if you were using this for the 3rd time, the 5th time, the 20th time, that would be really annoying. So we have to know our users to some extent, and what they understand about the robots, and how to gauge our human robot interaction based on that, so that people want to continue using them.
And maybe because you say we have to understand our users, so I'm wondering, both for you and Wendy, maybe, well, what is the right method to then get to understand what they are doing? So Wendy, I know your work, you've just left a robot around somewhere and see what people do. So what is the way that we get to understand the human and their interaction?
Well, one of the things that I like to do is stage different kinds of studies in the field and look at how people behave naturally, with the unnatural thing of having a robot suddenly in their midst. And one of the things I think is so interesting is that a lot of people are like, oh, it's a robot. Like, they've been promised for years by science fiction. They're not freaking out or like trying to understand what's going on. It seems natural to them, which is just the best to find out. So one of the studies we've run, we had people who were eating lunch, like, encounter a robotic trash can that was coming by and, like, you know, stopping by each table to pick up trash. And nobody was like, what's that? What's that doing here? People were like, oh yeah, I have some garbage, you know? And then the really interesting things where people had this, which we didn't expect, that people had this mental model that the reason why the trash can was coming by was because it wanted to eat trash. So they felt like they had to make trash to feed it, you know? And we were like, oh, that's not good. And then there was this one child that was just amazing. He was trying to get the trash belt to go across the room. So he was taking a piece of trash and then trying to bait it across the room. So it's these moments where you discover, like, oh, the natural mental model that you wouldn't think, but is the thing that everyone goes to, is that the trash barrel eats trash. Like, very often in human-robot interaction, we use what we call the H model, like another human, like maybe a busboy or somebody who pushes around a trash barrel. We know how people would interact with that, and we kind of expect that to be the model. But then all the time in the actual experiment, we find out that it's something else. One thing I will say is that even though they're not necessarily human model interactions, they're always social interactions. And that's always one of the most delightful things about looking at human robot interaction, that you can see the profoundly social nature of it. They ascribe intent to the actions that robots have, like Holly is saying. They expect robots to have some understanding of social proxemics and timing and interruption and social hierarchy, which normally they wouldn't, like why would that happen? But the kind of unconscious expectation is that that's there. And then the really cool thing is when those robots fail to do that, people have all these different ways of enforcing social norms. They like kick robots or bully them or give them dirty looks, and then they will actually escalate their things until the robot is like kind of forced to respond. And I think a lot of things that we see in these robot field experiments that are these very extreme cases of robot bullying are actually just the farthest reaches of this like norm enforcement that's going on.
Right. So sometimes the expectations break a little bit. I was reminded by your talk about my favorite amusement park in the Netherlands. If you ever visit, it's called the Efteling, where the garbage cans in the Efteling are big giants, or they look like giants. And when you throw garbage in them, they say thank you. So the kids, like with your garbage can, they keep producing garbage and finding garbage on the street to filter it. So I think there's a business opportunity there for you to sell those robots to the Efteling. Maartje, you've also looked at intentions and violations of intention. So what's your perspective on what makes human-robot interaction work?
Yeah, recently I started to get more interested indeed about these norm violations and how robots would fit into this picture, because we humans have this whole social norms network, and we actually also have a system to regulate it. Like we call people out when they violate norms, or at least we judge them in our head. And I'm currently still in the midst of data collection, or just got data in, so I don't have results yet. But 3 students of mine have collected data to compare humans and robots in the same sort of situations and see if we have the same norms, expectations from robots compared to human beings, and then see if there are any differences and how they are different and what that actually means for designing robot behaviors in the future.
Right. So if I got the perspective from all 3 of you a little bit correctly, then it seems like we have a sort of a natural tendency to project. So there is this artifact out there, this machine, but for some reason we treat it like it's human, or like it's an entity, an agent. Is that a correct summary, or are there nuances there? Maybe I need to allocate.
Oh, yeah, right.
Look, I think we all have a tendency to personify everything, right? Whether it's our pet's behavior or any other animal that we see. People name their Roombas, their vacuum cleaners, and iRobot tells stories about some of the packbots that were used in the war. After it blows up, the team sends it back and says, please fix this robot. We want this one back. And the same thing with the Roombas, right? People want their robot. They become very attached to them.
May I?
Yeah.
Indeed. And I think there's some sort of danger maybe in that, because if we personify these artifacts, we also have too high expectations, and that is maybe difficult with the trust situation, because then we may allocate too much trust to them. And what I also see from some of my experiments is that also all kind of stereotypes that we have in our human society are also transferred to robots. So think about gender issues, like we trust robots, female robots, we don't trust them to do more male tasks and vice versa. So yeah, there's an upside and a downside, I think, of this anthropomorphization.
Right. So it sounds like both of you are saying that we're treating our robots a little bit static. So we have this robot, we create some expectations of what it is, and even if our original robot breaks, we want exactly the same instead of maybe the upgraded version or the software update on it. Is that the case, or I mean, that's a little bit, Holly, what I sensed in your reply. Like we want the same robot as we're used to.
Well, I think, I don't know, it's a used to, I think it's an attachment, right? I mean, if my cat got sick, I would want my same cat back, right? I think it's in that sense, I was talking about the attachment, not that and I don't want a cat upgrade. I'm guessing Wendy has quite a bit to say on this too.
Yeah. I mean, I primarily do research in looking at non-anthropomorphic robots. So they look more like furniture, tables and chairs and garbage cans than people. They don't have eyes, but we also see a lot of social behavior. I'm always careful about the word anthropomorphization because it assumes that the social and the personified things go hand in hand. But even if it's not a person and you don't think it's a person, you still have certain behaviors that you have for living beings, like pets, for example. So I think in a lot of our research, we notice that people basically bring animal metaphors to things where they understand it's not a person, but they only have so many, templates for how they interact with things that aren't people. And so there's still this feeling of loyalty, concerns about trust, like real determination of like what's going to happen, some of the same fears, some of the same expectations. But they're profoundly social. Like people feel ownership. They have, feelings of affiliation or anger, and all those things happen even if it's not a person as a model.
Right. I see that in the meantime, there have been questions coming in over the chat, which is great, because you come up with things that I haven't thought of and that naturally fit the conversation. So we've been talking about comparisons between robots and our animals and environments. Shamsi, you have a question about comparison to voice assistants. Maybe you would like to ask the question yourself.
Sure. Can people hear me? Yes. Yeah, so I was thinking about this when I was listening to this panel, and I was thinking that, well, we have an Alexa at home and we have a Google Home. And the way that my kids interact with it is that they start off nice and polite, and then when they don't understand the question, and then they start yelling. And I often feel that there needs to be a stern reaction coming from the assistant saying that, okay, that was very rude. And I wonder if the robots have an advantage because one is that it's kind of like more, you can make it more expressive, and whether there's something in the humanoid form that can convey. And I noticed that Diana also has a similar question around empathy and kind of like that, yes, I'm listening to you, I'm reacting in a certain way, which you don't get in a voice assistant. I think there's an opportunity there, obviously, but I just wanted to hear your thoughts on, where you see the advantages are.
So a rephrase would be, do these robots need a body? That's one of my interpretations.
Yeah, if I can lead off, we've been doing some work looking at how people interact with like home voice assistants, and I think embodiment is important. There is some of these things that maybe a more humanoid form might be useful, but I think there are other things, like people very often don't notice that there's this listening agent in the room. And if you just think, if it was a person in the room and you just didn't notice them and you're having your conversation with your doctor or, your best friend, like it would be, the responsibility of that person to move around and shuffle and like draw enough attention to themselves that you understood the actual context. And that none of these voice agents do anything to draw attention to themselves if they don't think you're directly addressing them. And so I think like a lot of the things that we have as norms involve embodiment and physical movement, visual, you know, like visual distraction. And I think without that embodiment, it's really hard to draw on the social norms that people already have built in.
Do any of the other panelists want to add to that?
I think some robot systems may need to have empathy and others may not. I don't know that my automated car needs to really have much empathy. It just needs to be competent about getting me places, right? Whereas if you have a robot that's meant to be a caregiver for your grandparents, or it's working in a hospital, then we'd want to have more empathy in that system. So I think it really depends a lot on the actual application domain you're working in and how you design that.
Thank you.
I think, Naja, you have a follow-up on this question line, if I'm correct. Maybe over to you.
Thanks, Chris. Yeah, so like I was thinking, how would this interactions that we have with the robots, can we separate it from the interactions that we have with people? With, for example, lack of empathy with a robot, train us for lack of empathy with other people?
Yeah, I would like to respond to that. That is actually one of my concerns as well, because we seem to treat robots quite similar to how we treat other living beings. Then maybe we sort of forget who we are interacting with when we are switching back to humans, and then maybe we forget to be polite to people if we don't need to be polite to Alexa, for example. So yeah, that is actually one of my concerns as well. But yeah, I'm afraid only sort of time will tell us what will happen, although I would like to research it in advance, but I don't know really how. It's so difficult to do something that can only be done 50 years ahead of time, but actually want to know it before it actually happens. But that is a challenge.
I think, Wendy, this ties in with your ghost car project, for example, right? To look at the new technology. I have a related question that's inspired by Charity's question in the chat, but it's not exactly that question yet. Because how, in a typical scenario that you've looked at, that all three of you have looked at, how much time do we need to get accustomed to a robot or to that interaction setting? I can imagine, Wendy, the trash can that drives around that seemed to have gone more or less right away. Mm-hmm. But how have you looked at longer trajectories? How does our behavior change? Do we perhaps rely too much or not enough on these robots? Do we change in our interaction with them?
That's a really great point. So a lot of the experiments that we do are really short studies. We use what's called Wizard of Oz, like a person in the loop pretending to be the automation, or a simulation where it's, you know, software, like setting up the world to stage these little future scenarios. But those things are not really well suited to study long-term effects like longitudinal behaviors. And it can be really challenging to study longitudinal work without some working technology like Maartje's done. And so, I mean, I think the question of how we understand how behaviors evolve is like a really important one, but not one that I think the community has completely nailed down.
Yeah,
certainly. Oh, sorry, go ahead.
Yeah, like Wendy said, I did a long-term study during my PhD, which was over 6 months. But I started actually with 70 households with questionnaires, but the ones that I interviewed were 21. And yeah, by the end of the study, 2/3 had dropped out because the robot that I used was actually basically just your smartphone, but then in a robot embodiment. So yeah, that's then, you know, I do have long-term results, and I saw people adapting and changing their behaviors and integrating the robot into their daily lives. But then also the technology is so simple that we can't really, not easily at least transfer these results to the more advanced robots that we are using in short-term studies.
Right. So there's lots of opportunity for the PhD students that are paying attention today.
Long-term studies are hard though, right?
Yeah.
Because, you know, we were doing a long-term trust study and bringing people in to use a system that was meant to simulate an urban search and rescue robot. And on the last time, 2 of the 5 people that we had managed to get through, and you basically start paying people exponentially because they're worth so much to you after they've been working with your system a lot. And 2 of these 5 people didn't use the autonomy at all. We were trying to measure how much they trusted the autonomy, and if they used it longer, would they use the autonomy more? And at the end, both of these independent people, they didn't know each other, said to us, well, it was my last time using the robot, so I wanted to drive it. And it's like, you just blew up my study because you wanted to drive a robot. And we would have let people do that. But I think that it's hard to control a lot of these variables in long-term studies, even just getting people to come back or continue to use the system, that the robot has to keep working, especially if you put it into somebody's home. So these are hard things to do, but it's important, I think, for HRI to be able to do them.
Yeah, definitely. I want to shift gears a little bit. Andrew has an interesting question. Now, if I didn't know Andrew, then I would think he also would have liked to have Holly's robotic spirograph. But I know that he has a general interest in arts and in books. So Andrew, maybe you ask your question.
Sure. So I'm wondering how we might be using, how can we use art to gain some insights? So right now I'm reading iRobot for the first time, and going back to that empathy question, it's really interesting how the start of the book, there was this really beautiful description of how emphatic this robot is in the description. But art has been definitely used in many ways, for example, for AI, to try to understand how different outcomes might lead in different directions. So what do you think about that? And how could we perhaps use art, from videos to books to art installations, to inform us and to maybe conduct some of our studies?
I don't know about the 2 of you, but movies that show robots taking over the world and killing everybody are almost the bane of my existence. Although I must admit, ever since there was the DARPA Robotics Challenge, where there was a compilation video put together by IEEE of all these humanoid robots falling over with amusing music, I no longer get a question from the press about when the robots are going to take over the world. So I do thank the DARPA Robotics Challenge for that. But I think that movies tend to show a very negative spin on robotics, and it influences what people think about them. And I think it increases some of the fear when it's not necessarily, it's not warranted. I mean, we don't have robots that can do anything like the movie robots can at this point.
I like to work with the artists. I mean, I love that Holly is like working with kids on art. I feel like professional artists are actually trained to be really sensitive and aware of things that we ordinary civilians don't think about. So for example, when I walk into a room, I really am not conscious about what I look like from every different angle, but I can tell you any dancer is really thinking about, like, with every single move they make, like how that shows, how that performs in different places. And so when we think about robots performing physical gestures in a room with many people, like working with people who just have this sensitivity built into their normal everyday life is really important. And I think, we've had these experiences working with people who are sound artists, dancers, or improv artists who are like super, like really aware of what it means if you make a certain noise, if you hold a certain position, if you exercise a certain timing. And so we are really working with a lot of artists to kind of develop our sensitivities to these things that matter a lot in the things that we're designing, that engineers are just not trained to pay attention to, but matter a lot.
Right. Maartje, would you like to add to it?
Yeah, it's not really my expertise, but I know that people in our community are working with like speculative design and design thinking and future design thinking. Probably Wendy is maybe more familiar with all these terms, but I know these are techniques to help people think beyond what is possible today. And because if you, at least in the Netherlands especially, I think if you show a solution, then Dutch people will immediately tell you all the things that's wrong with your idea, because there are so many things that could go wrong, which is actually what I loved when I worked in the US, that no one really did that. It was like all thinking along and moving ahead. But I think these kind of techniques from design and yeah, that could really help shaping the future of robots as well.
Yeah, I can agree on the Dutch perspective. You had a slightly different question about moving away from the doom and gloom and the either or. So let's hear it from you.
Yeah, so thinking about the future of work, I think that in the very near future, we're going to see more robots in the workplace. And it seems likely that instead of replacing people altogether, we'll see people and robots working kind of side to each other. So my question is, how can we train, how should we change the training of people to work effectively and Shadan added kind of meaningfully while cooperating and coordinating with robots?
I can jump in. It's funny, we were talking about empathy earlier, and I was thinking a little bit on the reverse side, when what it really means to be empathetic to a machine. Like, robots are stupid, and they have limited capabilities, and understanding how they work and like what their limitations are is like a really important thing for me as someone that works with machines all the time. And I think that's a really difficult skill, because people bring in other assumptions. They assume the robot's mad at them or doesn't like them, or thinks they're not very smart. And like I think I wouldn't maybe actually frame it as robot empathy, but that kind of like basic understanding of how a robot operates gives people a lot of insight of how they should interact with them. And I think that's the thing that's important to the training.
Yeah, if I may jump into that, research has shown that it can go either way. So people's expectations can either be too high or too low. Both cases have been true. And we need to design robots somehow that, their behavior or their appearance or something that tells people to calibrate this mental image of what the robots can and cannot do. And also some other studies have shown that our mental models of a robot are quite robust. So even though we tell them in advance what the limitations of the systems are, people keep having these high expectations. And even then over time, when they are faced with facts that counter their initial mental models, then still they hold up to it and use the system in a way that is not designed to do, which is very interesting, which is why I love humans so much.
Might that just be the stubborn Dutch perspective, or is this something outside of the Netherlands as well?
Yeah, it was not my research that I refer to, so it must have been done in another country.
Okay, so not just the Dutch are stubborn in their perceptions. That's perhaps comforting to know.
There's a paper title right there. It's not just the Dutch who are stubborn.
Yeah.
So I think it's also important to think about not just training workers, but think about involving workers. So one thing that when we're doing HRI design is to get the people who'll be working with robots involved right away in the initial design. It's certainly something that we've done in assistive technology. It's required. You have to do it in assistive technology, because if you're designing something that someone can't use or it's not useful to them, then why are you doing it? And there have been cases where robot systems have been introduced in factories and the workers have refused to use them, or worse, they've actually broken the robots. They vandalized them. And so if you can bring people in to say, what are the parts of your job that you don't want to do that you could have something helping you do, and you're not being replaced, but how could we have a system help you? I think that would also help for adoption.
Yeah, that's a very nice perspective, this co-design and starting from a collaborative perspective. There's lots of questions still coming in on the chat, which is great. However, the time is limited. And I think it's useful to move towards a closing question. And the typical closing question that Andrew and Orit ask of everyone, so I'll ask of each of you in turn, is what is your vision of the future of work through your particular lens of human-computer interaction or human-robot interaction? Where are we headed? And this can be out of the box, or this can be very close. Maybe we'll do it in inverse order to how I introduced you. So maybe Holly, will start with you.
So I think I, like all of you guys, have been impacted by a recent situation to thinking about the future of work. And we've already been thinking about how people interact with robots, although for me, it's been largely people interacting in the same space. Certainly assistive technology, people are very close to the technology, if not with it. And so how do we start to think about robots interacting with these robots in remote locations so that we could be places that we can't be right now? We had looked at telepresence robots. My graduate student, Kate Suey, who's now working at Toyota Research, had developed telepresence robots so people could use it to go places they couldn't. They could go to museums and things like that. And could we have avatars for ourselves out in the real world? Is that something that we want? We were looking at ways to have a large number of robot arms and grippers to allow people to test their algorithms remotely. But now could we turn that and have that be a way for people to continue working in those factories or doing things remotely? So it's not just that you're testing, it's that you have some ability to use things remotely. So I think that being at home has really made me start to think about how could we take the work that we were doing and turn that for work.
Yeah, very nice. Same question for you, Wendy. What is your broader vision of the future of work through your lens?
Yeah, it's interesting. I think I'm also inspired by this time we spent social distancing, but I'm thinking a lot of what I'm missing about working with my colleagues, you know, my PhD students, and there's a seamlessness to the interaction, you know, and the way that we work together, the way we pass each other things without even like saying a word, you know, and I think that frictionlessness, kind of the invisibility of interaction, it's so seamless that you don't even think about it anymore. Like, I would love that with robots. I would love that, like, my desk, which is currently, you can't see, cluttered with all these things. It'd be great if I was just like, let's just clear the desk and the desk would clear, you know, like that would be, you know, the sort of magic moment for me. And I think that getting to that seamlessness is about shaving away so many little frictions, you know, here and there until it all comes together. But that for me would be the holy grail.
Right, thank you. And Maartje, finally, for you, what's your vision for the future of work through this lens of human-robot interaction?
Yeah, so my research takes more like a social psychology angle. So I see like every human society, but also the workplace, is basically a whole network of social connections and interactions. And robots have the challenge to be integrated in our social network. And they need to adapt to all our social interactions, arrangements, norms. I think that's the challenge for the design of robots, how to build them in such a way that they naturally integrate into our social world.
Great, thank you. Well, I've learned a lot about human-robot interaction today. I hope everyone else as well, but I'm quite confident they did. So I want to thank the panelists again, Maartje de Graaf from Utrecht University, Wendy Ju from Cornell, and Holly Yanco from the University of Massachusetts at Lowell. And with that, I'm going to give, you can do the virtual applause. I'll give the floor back to Andrew and Orit for some announcements, and make sure to stick around for the informal meetup.
Great, thank you very much for the speakers and for Chris for organizing this panel. We really appreciate it. I learned a lot and was left with much to think about. So I hope that these conversations will continue. And talking about continuing the conversations, next week, Ed Doran from Microsoft will be with us to talk about developing products for the future of work. So please join us. And I think we're going to stop the recording now and continue the conversation. Thank you.